ठीक है।
Hello. Can you hear me?
Good morning, sir.
Morning. Yeah. Good to see you. Somehow the Firefox is crashing, so I'm using my phone to access.
Okay, it's okay, sir. Fine. So, good morning to all of you. I think Professor Brozen is already with us. Can you hear the inaugural ceremony of this today's workshop on Latex for technical writing? So, this session is hosted by a PhD scholar, Priya Singh Gurjar. So, I request her to start the formal session. It is over, Priya.
Good morning, everyone. On the behalf of SCIS JLU, I warmly welcome you all to the two-day workshop on latex in technical writing, being held from 29th April to 30th April. In this inaugural session, we are honored to have with us Chairperson Professor R.K. Brojan Singh, special guest Professor Sandar Ahmed, convener of the workshop Dr. Kuwar Singh Mathur, and co-convener Dr. Rakesh Kumar Saroj. Thank you for giving us your valuable time and efforts. We are thrilled to have you all here, and we hope you are excited as we are to embark on this journey together. Now, it is our absolute pleasure to extend a heartfelt welcome to our esteemed speakers who will be guiding us through this workshop. This workshop is specifically designed to help you get comfortable with the latex. Whether you are a complete beginner or looking to refine your skills, we'll explore the basics of latex, including how to structure your document, citation, and also equation. This is going to be more beneficial for the researcher for mathematics oriented research. Now, I would like to invite the convener of the workshop, Dr. Kuwar Singh Mathur, Associate Professor at the School of Computational and Integrative Sciences, JNU. Dr. Mathur holds a PhD in Applied Mathematics from ABB IIIT Gwalior, and his contribution to the fields of biomathematics and applied mathematics gives us deep insights into complex biological systems. May I now request Dr. Mathur to kindly address the audience and share valuable thoughts. Thank you.
So, thank you, Priya. I think I am audible.
Dr. Mathur, we cannot able to hear you. Can you please unmute your mic?
Sir, I think your mic is off.
Yeah, okay. Now?
Now this is okay.
Yes, sir.
Okay, thank you. Thank you. So, good morning to everyone. This is Kumar Singh Mathur, the convener of this workshop and the faculty members of School of Computational and Integrative Sciences, JNU. Respected Honorable Vice Chancellor Madam, respected Professor Brijesh Kumar Pandey, Professor Deependranath Das, the Rector of the JNU, Professor R.K. Brojan Singh, Dean SCIS, and the Chairperson of this workshop, Professor Sandar Ahmed, our special guest, Dr. Rakesh Kumar Saroj, one of the convener of this workshop, and our distinguished resource person, respected faculty members, and my dear participants. It is truly an honor and a privilege for me to welcome you all to this today's workshop on Latex for Technical Writing that is organizing by the School of Computational and Integrative Sciences, JNU, New Delhi. As the convener of this workshop, I extended a very warm, heartfelt welcome to all of you, to all the respected dignitaries, our expert speakers, participants from the different part of the country and abroad, and to our hardworking volunteers who have been working tirelessly for the past few days to make this workshop possible. For this workshop, we received a huge number of applications, about 1,500 from across the countries and even a few from the outside of the countries. Since the seats for this workshop are limited, so it was truly a challenging task to shortlist only 400 participants. And this tremendous interest clearly reflects not only the importance of LaTeX in technical writing today, but also the growing enthusiasm among students, researchers, and the faculty members to learn and adopt this valuable skill. In today's world of academic and technical writing, the clarity, accuracy, and the professional presentations are extremely important. Whether you are writing a research paper, preparing a thesis, or making a technical report, or designing an academic presentation, or something else, the way you structure and format your document matter a lot. And for this, LaTeX is an extremely powerful tool. As many of you already know, LaTeX is a typesetting system that allow you to focus on your content while taking care of the professional layout of your document. So unlike regular word processors like the MS Word or any other processor, LaTeX give you much more better control over the important things like the structure of the document, writing complex equations, adding references, making tables, figures, and linking different sections. So it is widely used by the researcher, not only in the science, engineering, mathematics, even increasingly in social science and humanities also. So this workshop is designed not just to introduce you to LaTeX, but to help you deeply understand and practically use it for your academic writing needs. We are truly fortunate to have a group of highly experienced experts with us from some of the most prestigious institutions like IIT Mandi, IIT Delhi, IITM Gwalior, Varanasi, and Manit Bhopal, and even Pandit Ravi Shankar Sukul University, Raipur, and some are from Melbourne Polytechnic, Australia. And each of our speaker will share their expertise, practical examples, and applications. So over the next 2 days, you will have the opportunity to learn something new about the LaTeX and document preparation using the LaTeX. Here we have carefully planned the session to both keeping in mind both the practical and theoretical approaches, with enough time for your question answers and hands-on exercises. I encourage all of you to take full advantage of this opportunity and participate actively. And if you have any doubt, then you can ask without any hesitation. So at this point, I would like to express my deep thanks to all our distinguished speakers who accept our invitation in this busy schedule. Even the examination is going on everywhere. So we are truly grateful for your support and your willingness to share your knowledge with us. And a very special thank to our moderator, technical team, and the wonderful student volunteers. So your hard work behind the scene have been invaluable in organizing this workshop. And finally, to all the participants, thank you for your enthusiastic response and your commitment to learning. We hope that by the end of this workshop, you will have not only learned new skill, but will also feel more confident in using LaTeX for your future academic and research writing. So once again, a very warm welcome to each and every one of you. Let us make these 2 days a wonderful journey of learning, sharing, and growth. So thank you very much.
Thank you, sir, for your warm and thoughtful welcome address. Your words have truly set a positive tone for this workshop. We are specifically grateful for your vision, leadership, and commitment that have been behind the successful planning and execution of this workshop. Now it is my privilege to invite our esteemed special guest, Professor Sandar Ahmed. We are honored to have him with us today. Over to you, sir.
Thank you. Can you hear me? Am I audible to you?
Yes, yes.
Yeah. So, thank you for inviting me, and it's a great pleasure to be in the company of the organizers. And I congratulate Dr. Mathur for taking this initiative. LaTeX document formatting is very important for communicating our mathematical and other concepts to the audience in an unambiguous manner, so that what we communicate, what we write, is actually what we mean. So that is we were recently discussing with among our friends that document formatting systems, how we communicate and give our document to others, are typically classically referred to as WIS-WIM. That is, what you see is what you mean. That is called WIS-WIM in abbreviation. And what you see is what you get. That is the kind of document formatting where you already see the fonts, you see the formattings, etc., the graphics. And so WIS-WIM formatting systems include markup languages, and LaTeX is one of the oldest and most popular, one which very rich libraries for representing the mathematical and not only mathematical but other formatting requirements of documents. You will learn over the next coming days, 2 days and next sessions, about the intricacies of the syntax and possibly how it has evolved, but it's my turn to just highlight the importance. And so I hope that you will, in the next 2 days, you'll become experts in this very important skill set in your research. And after you have done your research, how to communicate it well, formatting documents, formatting CVs, in a very beautiful typeset format. And the subject the field has evolved from writing the command line codes for LaTeX to today much more convenient, and even document sharing has become possible. Some of the ideas have been taken from other document formatting systems, such as document formatting, collaborative editing, etc. So we'll learn about them in the coming sessions. Today it is on behalf of it's not I'm on behalf of nobody actually, but in the company of the organizers, in the company of the dean of our school, and with the support for everybody, I thank all of you for being here and wish you all the best for the learning opportunity that has been created for you. Thank you very much and welcome again. Yes, over to you. Who is campaigning, Priya?
Yes, I would like to extend our sincere thanks to Professor Sandar, who is a professor at the School of Computational and Integrative Sciences, JNU. His research focuses on protein DNA interactions, genome assembly, computational biology, machine learning, and deep learning applications in biology. He is recognized for highly cited publications in bioinformatics and nucleic acid research. Thank you, sir. Now we are delighted to invite our chairperson, Professor R.K. Brojan Singh, professor at the School of Computational and Integrative Sciences, JNU. He holds a PhD in physics. His research focuses on complex systems, stochastic and nonlinear systems, network theory, and mathematical biology. He develops complete emergent behaviors in biological systems, including genetic oscillators, biological rhythms, cancer dynamics, brain disorders, and also synchronization. May I now request Professor R.K. Brojan Singh to kindly deliver his invaluable thoughts. Over to you, sir.
So good morning, everybody. Can you able to hear me?
Yes, yes, we can hear you. Yes.
Thank you very much, Priya, for your kind introduction. And thank you very much, Dr. Mathur, So I'm really happy that you have take this particular pen, not only beneficial to the students and the faculty members, but also to all the people who are working on the scientific and research contents and all those things. And probably taking this particular advantage, I just wanted to highlight a brief introduction. I will not take too much time. And our school was initially known as the School of Information 2001. And at the beginning of the 2001, we have diploma in bioinformatics for the first time in India. And it was then after that we have a series of courses, MTech in systems and computational biology and many other things. And now we have in 2010 onwards, our school has been named as the School of Computational and Integrative Sciences. And we have three distinct courses. One is MSc in Computational and Integrative Sciences, and it has two streams. One is Computational Biology group, and the other one is Complex System. And the second one is PG Diploma in Data Analytics, and third one is the PhD program. And these three programs are still running over here. And we have research scholars in our school, and around about 93 MSc students have been graduated from our school. And we all the faculty members in our school has diverse backgrounds, starting all the different disciplines. For example, let us say mathematics, physics, chemistry, biology, then computer science and engineering, and so on and so forth. All the faculty members from these different disciplines are gathered together, distinct in the disciplinary school. And our first area is that using these different techniques from different disciplines to address the complex behavior of the computational biology and the complex system. We have a high performance computational facility over here, a specific facility over here, which we extensively work on the computational aspects in the computational biology and the complex systems. A small library, and so we have all these facilities. And if all the participants wanted to visit our school, you are warmly welcome, and we are happy to show our school and the ideas of and the trust areas and the faculty members and so on and so forth. And this particular conference, it is workshop in some sense. It is very important in the sense that nowadays, if you look at the heaviness of this particular Latex programming, Latex kind of this documentation in writing the scientific papers, books, and any kind of documents, it has been extensively replacing the traditional aspects of the writing of in the traditional Microsoft Word and so on and so forth. And around about 80% of the scientific journals, if you look at it, it has been converted to submit their papers in the Latex format. And they are and the authors are highly encouraged to write in Latex and submit in the respective journals. And this, in this particular perspective, even in our research methodology part also, we have included this particular extremely important kind of Latex documentation and the learning process in our research method. And we do hope that in the coming 2 days, we'll be learning a lot of things in the deep aspects of the Latex documentation and how to write very complex equations and all those things in a very easy manner in the Latex format. And I really from my on behalf of the school, I really thank all the speakers, esteemed speakers, for taking this pain and to they will be giving valuable kind of talks in the lectures in the conference, and we'll be learning a lot from you, sir. And this particular conference will be highly benefited to the, especially to the students, and not only the students, but also in the particularly to the faculty members who are generally writing in the traditional kind of documentation, and now it is high time to replace those traditional documentation to the latex format. So with this few words, and Dr. Mathur and the organizer of this particular workshop, I really thankful to you for taking this particular pain, and this will not only beneficial to the school but also all the wider audience in this particular conference. And thank you very much, Dr. Mathur Singh. And with these few words, I would like to end. And so I wish you all the best for this particular conference. Thank you very much. Over to Priya.
Thank you, sir. We are sincerely thank our esteemed chairperson for the insightful and inspiring speech, sir. Your words truly enrich the spirit of the workshop. We are grateful for your time, leadership, and thoughtful guidance. Now, we are honored to welcome co-convener of the workshop, Dr. Rakesh Kumar Saroj, Assistant Professor at the School of Computational and Integrative Sciences, JNU. Dr. Saroj holds an MSc and PhD in Biostatistics from the Institute of Medical Sciences, Banaras Hindu University. Dr. Saroj's work is in statistical methodologies with public health applications is a great contribution to the advancement in understanding and addressing health challenges through data-driven approaches. In addition to this, he is also a member of the editorial board for Social Sciences and Humanities, open published by Elsevier. May I now request to Dr. Saroj to deliver the vote of thanks. Over to you, sir.
Thanks, Priya. Okay. Yeah. So the respected deans are here, and our guest speaker, Professor Sandar Ahmed, and this is very important for the every research scholar, yeah, all the faculty related to latex and all the workshop. So because sometimes it's very needy to be related to some question is some mathematical formula to write out, so we can't able to do that in word, all those things. So it's very needy and very important for the all research scholar and who are doing the very good research, and lots of nowadays a lot of even research publication and research journal, they are asking the format of that. So this is on behalf of that, I am Dr. Saroj. I am the co-convener of this workshop. And thanks to again our Dean Sir, Professor R.K. Bhojan, our guest speaker, Professor Sandar Ahmed, and as well as our convener, Professor, Assistant Professor Convenor Singh Mathur Sir. And apart from that, behind the back, all that's a research scholar, that without their like support, we can't do that. So then I want to thank to those like IUC, Priya, Shivani, Sudhanshu, Sasang, and Priya. So again, and participants, most welcome to all of you also. And this is 2 days workshop, so very rigorously have to go on. And again, I'm thank to all everyone. And I'm sorry for again to those who are not shortlisted, maybe some colleague are here with them. So we are online in the YouTube and also. And you can convey the message to those who have not got shortlisted. We'll try to provide our recorded videos. Those. So again, we are sorry for, and again, most welcome to all of you. Thanks to entire team. Again, thanks to our dean and Sandar sir. Again, thanks to our Professor Convenor Singh Mathur and student. Thank you, sir.
Thank you so much, sir, for your valuable contribution and continued support. Thank you, sir. A huge thank you to all our speakers and facilitators today. Your knowledge and insights have given us a fantastic start to this, joining us today for an exciting and insightful workshop. We look forward to interactive sessions and will enhance your technical writing skills using latex. We'll start our first technical session in a short while.
5 minutes. Yeah.
5 minutes will come for our.
Thank you.
Unmute. You are unmute, sir, I think so. Yeah.
So thank you. Thank you to all of you. And start our first session. Yeah. So, good morning and welcome back. And in this session, IT Monday, Professor Neetu Kumari. So, welcome you, ma'am. And for the formal introduction, I would like to request IUC, the PhD scholar of this school, to moderate the session and to introduce our resource person. So, it is over to you, IUC.
Good morning to one and all present here. It gives me immense pleasure and joy to welcome you all to this highly anticipated workshop on latex in technical writing. To begin the session, I would like to invite Professor Neetu Kumari ma'am. Dr. Neetu Kumari is an associate professor at Mathematical and Statistical Sciences, Indian Institute of Technology, Mandi.
with a strong background in mathematical modeling, dynamical systems, machine learning based modeling, nonlinear dynamics, chaos theory, and differential equations. She holds a PhD in applied mathematics from Indian Institute of Technology, Dhanbad, where her research focused on modeling dynamical complexities in diffusion driven ecological systems. Additionally, she earned her MPhil and MSc degrees from the same institute. She has held key academic positions, including visiting senior scientist at Clarkson University, USA, and has been actively teaching undergraduate and postgraduate courses at IIT Mandi since 2010. Her research has resulted in over 25 publications in leading journals like Solitons and Fractals, Mathematical Biosciences, and Natural Resource Modeling, covering topics from ecological pattern formation to the mathematical modeling of infectious diseases. She has guided multiple PhD students and delivered invited talks at prestigious conferences such as SIAM meetings in the USA. Her contributions have been recognized through several distinctions. Additionally, she has served the Institute in numerous capacities, coordinating MSc programs, chairing student welfare and campus development committees, and supporting daycare and health services. Also, she is an active reviewer for journals including Ecological Modeling, Applied Mathematics Letters, and Nonlinear Dynamics, and is a member of the Society for Industrial and Applied Mathematics and the Indian Mathematical Society. Dr. Mathu, ma'am, we warmly welcome you and are eager to learn your perspectives on latex writing. Ma'am, I welcome you on behalf of the organization and everyone to give you insights on the topic Introduction to Latex and Creating a Basic Document. Over to you,
Thank
ma'am.
you very much, Priya, for such a nice introduction. So I'll share my slides. Please let me know if it is visible or not.
Yes, ma'am, you are visible and audible.
Are my slides visible?
Yes, ma'am.
Yes, ma'am.
Okay. So at the outset, I would like to first thank the organizers for inviting me to give a lecture here. And actually, it's a very important topic that you have chosen because when you talk about academic writing or scientific writing, then the appearance of the document actually it has lots of importance. And when you talk about writing it with LaTeX, then it actually improves the appearance of the document a lot. So it's a very nice topic that you have chosen here. And I would like to stop my video so that we have a better internet connection. I can see there's some issue here at my end. So yeah. All right. So I think my voice is clear, right?
Yes, ma'am.
Okay. Thank you very much. Thanks for telling that. Okay. So let me start it without wasting time. Let me start my lecture. All right. So here we talk about what is LaTeX. So even if some of you might not be aware about what is LaTeX, I hope that at the end of my talk today, you will get a pretty good idea what is LaTeX and why should we use it and why should we use it over MS Word. Okay. So if you talk about LaTeX, LaTeX is not just another word processor. Rather, it is a document preparation system. All right. Or you can call it as a typesetting system. And it is specifically designed for the production of technical and scientific documents where precision and structure matters. All right. So when we are preparing one particular document, we have to actually, if you're doing it in the Word, we have to take care of the content as well as how it looks, the structure. But when we talk about LaTeX, that if you are using the LaTeX for the typesetting, then we only have to focus on the content. We don't have to worry about how it's going to appear because the LaTeX takes care of it by itself. So if we talk about the origin of the LaTeX, so initially it was developed by Donald Knuth in 1986. It was known as TEC program, and later it was further developed in 1994 and was readily available and was done by Leslie Lampert. I'm giving the references here also. One is interested can see. All right. Again, I already mentioned, but to be a little bit more elaborate, why should we use LaTeX? So there are several benefits that you can see when you use LaTeX. All right. Especially when you talk about academic and scientific communities. First of all, we see that the LaTeX is portable and free. You don't have to pay for it. They're available online. You can just simply download it, install it, and start using it. All right. It is also very good for producing documents which are looking professional, very professional and structured. When we talk about complex contents such as mathematical equations or multi-level references or citations, figures, tables, all these things can be included in your document using LaTeX effortlessly. It's not that you cannot include it using Word or anything, but if you're using LaTeX, efforts are way, way, way less. Then also we see that there are complex structures such as footnotes, references, table of contents. All these things can be bibliographies. All these things can be easily incorporated, and the complexity is way, way less in LaTeX. So that's why LaTeX is actually highly reliable when dealing with large documents. For example, if you are writing your thesis, PhD thesis, or master's thesis, so you can actually rely on LaTeX very nicely. Now, when we talk about comparison between, is there any doubt? I can see it. Okay. All right. So if anyone has any question, you can actually open your audio, and you can ask me because I'm not able to see the screen on the other side. All right. So when we talk about LaTeX and MS Word, if you compare these two, so LaTeX actually focuses on the content, and you don't have to worry about the appearance. I already told about this, that you can peacefully work on your content, and the appearance will be taken care by the LaTeX. Here, you don't have to manually format the references. You can actually create a BIF file. And once you have created the BIF file, you can simply call it, and it will take care of cross references and everything else. I'm going to talk about it also in a bit. In LaTeX, you focus solely on writing the content, and the system automatically manages formatting according to the predefined style. So actually here you define what style of document you want your document to be. So once you have defined the style, the LaTeX will take care of it, take care of the appearance. All right. Now, if we try to see or compare our traditional typesetting or system or word processor, that is our MS Word. That is being widely already, still today also, it is being widely used by many of the scientists and researchers. So when you compare your MS Word with LaTeX, so you can see that initially you will see that the MS Word, you have some ease, efforts are less, time consumption is less. Till the time the complexity of the document is less. The moment you include more complexity in terms of figures, in terms of equations, in terms of tables, then you will see that eventually the effort and the time consumption in writing the same content in MS Word is becoming higher and higher. And at some point of time, you may feel that it is quite impossible to arrange your documents if you are having lots of equations, complex equations in your document, right? However, if we talk about LaTeX, initially you have to put little bit of more effort than MS Word in order to install the LaTeX. Then you have to learn how to run it. If there are some errors that you have to take care of, resolve those errors. But eventually, as the document complexity increases, you can see here, the LaTeX gives you an upper hand over the MS Word in terms of time consumption, in terms of its appearance, effort, and everything. Okay, So now that we understand that there are lots of advantages of using LaTeX over the traditional MS Word, can we start understanding how? So as I said, if someone is not aware of LaTeX as well, my talk would help you to give a pretty good idea how to start, from where to start. So the first point where you have to start is that you have to install the LaTeX. As I mentioned, LaTeX is available freely online. So you can install the LaTeX. So it's very straightforward. You have multiple options depending upon your operating system. If you are on the Windows, all right, then MikTeX is actually the most popular distribution that we use. All right. If you are a Linux or a Mac user, then you can install the TechLive. Okay, TechLive is widely used. Now, in case you say that you don't want to install anything and you still want to use LaTeX, then you can use this Overleaf. Overleaf is available online, and you can simply use Overleaf, which is an online LaTeX editor and accessible from any browser. All right, and it is actually great for beginners because it offers a user-friendly interface, collaborative features, and real-time preview. All right. Now, once you have installed the LaTeX, now how to set up LaTeX for Windows and Mac? So, in order to for a complete offline setup, the Window users should install MikTeX. All right, and the MikTeX is available here at this site. The complete MikTeX package you can download from here and install it. That's miktex.org. And in order to install an editor like WinEdit, so WinEdit or Technic Center, you can go here on these two sites, and this will help you to write and compile LaTeX document easily. WinEdit and Technic Center. Now, in order to view the document that you have created, you can either install this Ghost script or GSView, or which is actually nothing but it's another way by which you can see your document prepared, or you can use this popularly known viewer, that is Adobe Acrobat Reader, that is PDF. You can simply install the PDF. Now, Mac users can install TechShop, iTechMac, or TechMaker for editing your document. And no matter which platform you choose, the installation is generally very simple, and once done, you are ready to write documents locally without needing the internet. Now, once you have first you have prepared your LaTeX document, now you have run it. Now, once you have run it, then you see the output in different formats. What are the different formats that your document comes out in? So, some of the formats I have mentioned here, that is .dvi. Okay, so this is also known as, so once you run the LaTeX, it produces DVI files, which is also known as device independent files. Okay, so these can be converted into PostScript or PDF files, either of it, depending upon your requirement for final output. And for better compatibility with word processor, LaTeX can generate RTF files. All right, it increases the compatibility with word processor. And for web publishing, if you want to publish a document online, then actually you can use the output in the HTML format. Okay, so most commonly today, people compile directly to PDF because of its universal compatibility, and also it's quite professional.
Excuse me, ma'am.
Yes.
Sorry to interrupt you.
Yes.
Can you tell me something more about the rich text format, please?
Rich text format.
Yes, ma'am.
So this is a format which, if you are using the Word, then you can actually use the rich .rtf extension, and you can easily access it from with the help of Word. Also, you can actually find it the more details in the books as well. Yeah, you can use it. So the benefit of using this RTF output format is that it is much more friendly with the word processor. Okay.
Okay, ma'am. Thank you.
Okay. All right. When you are creating a document using LaTeX, so what is it that you do? First of all, you create a text file. So the text file that you are creating. Yes, sorry. Is there any question? Okay, so when you are creating the document, so first of all, you will create a text file. A text file would be, so basically a LaTeX document will have two parts, the preamble and the body, all right? So I'm talking about, first of all, the text file that you have created. It includes both preamble and the body, and the file name would be file.text. Once you run it using the LaTeX program, the output would be, most of the times, the output that you're getting is a DVI file of certain name, file.dvi. This is your device independent output. All right. Once you have got this output, now you run the device driver, and then you get the output file, that is file.ps or file.pdf, either in the PostScript form or PDF form. This is how we generally create a document using LaTeX. Once we have created the document, a document structure using the LaTeX, so now, as I said, it has both the parts, preamble and the body. Okay, so what does the preamble include? So the preamble would include, so here we define the document type. All right, so this is the preamble. Here we'll define the what document type you want to have, and then the page layout, and we will also install any packages which we might require for our document. For example, if we want to insert figures, so we'll insert a package that would insert the figures there and formatting. Okay. So it's like you're setting the stage before actually the performance begins. You are setting everything on all, and then you will finally start writing the document. All right. Now the body. The second part of this LaTeX document is the body. So body is where you actually write your content. The main content of the document is written here. Your text, equations, tables, figures, etc. Everything would be in the body. All right. So here, unlike Word, we need to define number of things in preamble, as I already mentioned. You define the package, document class, everything. Now let us dive a little bit into the LaTeX, how it looks like, the LaTeX document. As I said in the beginning, file.text. So let us look a little bit into it. So the preamble that we talked about, that there are two parts of LaTeX document, preamble and body. So the preamble, a general preamble looks something like this, as we can see here. It's a typical preamble for basic LaTeX document. All right. So here we define document as an article. All right. We set the paper size. So here it's A4 size paper has been set. And then we import useful packages. So here we have imported the package like AMS Math, AMS THM, AMS Symbol, AMS Fonts, and so on. For symbol, math, fonts, and so on. Then, as I mentioned, that in case you want to insert figures, so then we'll use package graphics, EPS fig. All right. It's for handling images. And the book tabs is for clean tables. You want to have a good, nice looking table, so we'll use book tabs. Hyperref, we use hyperref for hyperlinks and cross references. If we want to refer something, we have used it in the in some figure, we want to use it in the text. So for the cross referencing, we use hyperref. All right. Now each package extends the power of LaTeX and makes document creation easier and more professional. That's why packages are very, very important part of the preamble. Here we'll go and if you want to see how does it look like in the LaTeX. So here I have put this small screenshot of this LaTeX. So here, this is how it looks like in LaTeX. So on document class, you have defined your document, which is of type article, and then you have the paper size, the packages, and then other packages that you require for table, for figures, and for captions, hyperref, cross-referencing, and so on. So here I'm defining it a little bit elaborately, one by one, that I have used previously. So here, this symbol that we use, a person symbol, it is symbol is a LaTeX version of commenting a line. So whenever you want to comment your line, we'll use this ampersand symbol in the beginning of the line. Okay, anything after it on the same line would be ignored. Then document class. So this document class 12pt. This says we want an article document with 12-point font. Simply this means this. Okay. If we go to use package A4 paper geometry, it sets the paper size, defines the type of the paper we want to use. And now use package AMS Math, AMS THM, AMS SYMB, and MS Fonts. It is a suite of math packages that let us use the align environment to write equations and other helpful math things such as symbols. All right. So it will not just help you to include the mathematical equations and all, but it will also help you to align them nicely so that it looks pretty, looks structured actually. And some of the graphic packages that we use, that lets us insert images and figures without any difficulty. For example, one which we used previously, it was graphics EPS fig. All right. So similarly, the other, for example, use package caption. This allows us to use label figures. When we want to label figures, we'll use this package. The use package set space, it allows us to use double spacing and single spacing. This use package PS Latex, it allows us to use a Times News Roman font. All right, now we will see an example of one of the basic document in LaTeX, and I'll also show you when you would run it, how does it look like. So this will give you some idea about how does one LaTeX document, simple LaTeX document looks like. Okay, so this is one of the simplest LaTeX document I have created. So it starts with this document class article. So it declares the document type, declares that the document type is article. So we're preparing an article. Then we open the document. For opening, we'll use this command /begin document. And whenever we open a document in the LaTeX, we have to close it, as like in C program. Once you open it, open a loop, you close it, open the program, then you have to close it. Similarly, you have begin document and then end document. Once you have between these two, begin and end, we will use whatever we have to write here, right? Sorry. Okay. I guess there is no question.
No, ma'am.
Okay. So between these begin and end commands, whatever content you want to appear, you want your final output to appear like, you will put it here in between. So here I have put just hello LaTeX. Now let us see how does it look like when we use it in the LaTeX. So the tutorial here, this is the LaTeX window, using a text studio, and this is how we will write. So this is your document class 12 PT article. We have begin the document, and the content has been written in between the begin document and end document. Once you run it, so this is where we'll use to run this green run symbol. So once we'll run it, you will see output like this. Hello LaTeX. So whatever is written in between this begin document and end document, this would be displayed. Now, we have this option of formatting the LaTeX as well, formatting the document as well using LaTeX. So LaTeX offers very simple commands to style your text without using any mouse clicks or toolbar buttons. Okay, so you will use this command /textbf, and inside it, whatever inside it bold. So whatever you're writing within this textbf, that will be coming out as bold. For italics, the command is text it. For underline, we'll use /underline. All right. So this consistent syntax ensures that your formatting remains embedded within your text itself rather than being applied manually, making large documents easier to maintain and modify. All right. So you don't have to actually select and choose it and say that, okay, convert it into italics, convert it into bold. Simply you give the command, put it right inside this, and you will get your text formatted accordingly. So this is how these commands would look like when you are using it in LaTeX. And once you run it, so you see the /textbf bold, whatever is inside, it is coming in as bold. Whatever is written inside this command text it, it is in the italics, and slash underline, this is underlined. All right. So these are some of the formatting text commands in the LaTeX. Now, we can also use in LaTeX, and a new paragraph is automatically created when you leave a blank line in your source file. All right. So you can create the paragraph just by leaving a blank line in your source file. If you want to simply break the line, then you will use this command, / or / new line command. By default, the LaTeX indents the first line of every paragraph. But if you want to prevent this, you can use no indent. This no indent, you can use it. Okay. You have to use it at the beginning of the paragraph. So I'll show a tutorial here for this. Okay. So here we have used this / new line and then no indent. So when we are putting no indent, then there is no automatic indentation done by here. We have used no indent, so no automatic indentation done here. It's just written, whatever content you have written after this is as it is. For line breaks, actually you can either leave the line or use this. You can new paragraphs are created with a blank line. Okay, line breaks. Let us come to some of the special characters that we have in the LaTeX. So LaTeX reserves some characters for special meanings, such as this $sign. It is used for math mode. Whatever you write in between, that will be mathematical. And then this hash sign, it is used for arguments in the macros. This ampersand sign is used for comments, and so on. These are the other special characters. Now, if you want to actually display these symbols as regular text, then you need to escape them with \. So if you are using the \ in front of it, only then it will be shown as a special text. All right, so let us see a tutorial here. Okay, so here these are special characters with special meanings, but here when we are using the \ in front of it, this is how the characters are displayed. We can see that. Okay, and when we're not using the \, actually we can use it to write maths and so on for this one for commenting and so on. Okay, now there are various packages, as I mentioned in the beginning, that any LaTeX document has two parts, preamble and the body, where in the preamble we use various packages. So packages are basically the add-ons which expand the LaTeX capabilities. Okay, so you include them in your preamble using the command /use package, and then you can write the package name here. Now, some of the popular examples that include some use packages that are included mostly are AMS Math. It is for math typesetting. Then graphics. This package is used for inserting images. Geometry. This is for page formatting. Then hyperref. This is used for hyperlinks. So packages actually make LaTeX infinitely flexible. There is a package for almost everything you might need here in LaTeX. Now, as I said that when you're using LaTeX, your document is very well structured, okay, and appearance is very professional. One of the reasons why that happens is that the LaTeX provides a simple but powerful way to organize your documents using sections. So if you're using this command /section, you can create chapters, sections, subsections, and even subsections using simply the command /section or /subsection, /subsection, and so on. All right. For example, I'll just show here. So this is one snapshot that I've taken from the LaTeX. So here /section, I have used the section name. Then I've created the subsection using /subsection. Then I'm writing the subsection name and then subsection. So this hierarchy, actually, it is very, very important, especially for longer documents. LaTeX can automatically generate a table of contents based on the headings, whatever heading you are mentioning. So here, this is a /section is coming as a the bigger section, and then this subsection name smaller than the previous one with this numbering that is itself taken care of, and then further subnumbering and so on. This is very good feature of LaTeX. We don't have that in Word actually. Now lists. What are lists that we use in LaTeX? So lists are basically they're a great way to structure your information very clearly. You can create bullet lists using the itemize environment. So here I'm using the command for it as /begin itemize. Now whatever you're writing within this /begin itemize, you will get your content in under the bullets. If you want it numbered, then you will use numbered list enumerate. So if you are using this command /begin enumerate, whatever you are writing inside this, you will get it in numbers 1, 2, 3, and so on. And each item inside the list is introduced with the item command. All right. So here I'll show this tutorial to you. And whatever, just a second. Yeah, whatever you're writing under this /begin description and then item, so it will be as a description. There will no numbers, no bullets, nothing. So here is an example you can see. So first of all, we have defined document type, article, 12 point font size. We, as I mentioned, will begin document and an end document. Within this, whatever we want to write, we'll write. Now we are doing /begin itemize, item A, item B. Now we are ending the itemize. Then again /begin enumerate, then item A, item B. Where actually the content is same, but you will see the outputs are different in all the three cases. Then item A, item B. Now let's see how does it look like. So when we are using begin itemize, we are getting those whatever we are writing under this heading item, we are getting it in the bullet form. If you are writing it enumerate, we are getting the output in a numbered way. And then /begin description, it is as a item A, item B. It's simply the whatever description was there, it is displayed as it is. So these are lists in the LaTeX. Now there are various fonts and sizes that are also you can write your document in a different font and different sizes. But what is the command for this here in LaTeX? So you can write /tiny, and then from tiny you can go to /small. So /tiny would give you the smallest font available in the LaTeX. Then you can go to /small, which is a little bigger than /tiny. Then you can go to /large, which is again bigger than small, and then finally to huge, /huge. Okay. And you can also switch font families using text TTT for this is for typewriter font, /text SF, this is for sans serif font, text RM, this is for Roman font. See a tutorial for it a little bit. So this is how it will look like when you are using writing this different fonts in the LaTeX document. You have first defined your document type, then you have begin your document, and then /tiny, /huge, huge, and then different fonts also I'm displaying to see what is the difference between all these fonts. So once you run it, you have this tiny size, huge, and the fonts are different. Okay. Now, as I said in the beginning as well, that the appearance or the structure of the LaTeX is much better. So here you can use different colors as well to beautify or to professionalize your document. All right. So you can use this package, use package X color for using different colors of font. All right. So once imported, you can actually easily add colors to the text using the text color and then color name, whatever color you want here, red, blue, whatsoever, and then the text. What text you want to see in colored format. Right. For example, I'll show you one small tutorial here. So here we have defined the document, and then now we are calling this use package X color. Now inside this begin document, we are using text color red text, and /text color blue text, and /text color black text. Now we'll run it, and you see whatever color we mentioned here, we are seeing the text in the desired color. So colors can actually help highlight key ideas, differentiate between sections. You can also use it to make your presentations more engaging. Now, how to insert the figures in LaTeX? How do we insert the figures in LaTeX? So for inserting the figures in LaTeX, we actually use this package graphics and slash include graphics file. So this would help you to insert a figure in your document, but you can actually insert your figure at different positions. How is that decided? So the various positions of the figures, you can decide it using this command H, or you can mention T, D, P, and so on. So here, if you use H, so here H means here, so it will be wherever you are writing it, there the figure will be inserted. If you're writing T, then it will be inserted at the top of the page, B, bottom of the page, and so on. Okay. Once you have inserted your figure, then once you have to write down the figure. So for that, you can use this slash caption. Okay. And then you can also use the label for labeling a figure. So I'll just show you one tutorial on this. Yes. So here I first of all use the use package graphics as to insert the figure. Then I have used this use package caption to write the caption of the figure. Now begin the document here. Begin figure, include graphics. Now I'm writing including the whatever figure I have. I'm writing it here, and then caption, a reference of book for the LaTeX, and then end figure. So simply by doing that, we can include the figure in your document, something like this, with a caption here mentioned. Okay. Yeah. Here comes the most interesting and the most useful part of LaTeX. That is writing the mathematics.
Excuse me, ma'am.
Yes.
Sorry for the interruption.
Yeah.
But can you show us how to use the positioning characters for adjusting the image position?
Yeah, I'll show you. Yes. So here right now I cannot show you. I'm not running the LaTeX actually. This is a screenshot that I have taken. So I'll just explain to you here. So here there are different commands that we use for positioning. So if you simply write H, it will be wherever you're writing it, there it will be inserted. Okay. If you're writing, if you're using T, then it will be, the figure would go to top of the page. If you're writing this command B, it will go to the bottom of the page. All right. And if you want to override whatever the LaTeX inbuilt positioning is there, you can simply use this exclamation mark. This is for different positioning of the photo of the figure. I'm sorry, I cannot use it here. I cannot show you here in this LaTeX because it's something that I've already taken. For that, I'll have to go back and run it. So I hope it's clear by that explanation.
Yes, ma'am.
Okay, now if I come to the mathematics in the LaTeX, how can we put whatever mathematical equation or the terms that we want to use in mathematics, we can put it under the $sign. All right. So you can embed, you can simply embed inline equation using $sign. For example, and for fractions, you can actually use slash fraction AB. So I'll just show you a tutorial that will make it easier to see and understand these mathematical these symbols, how you use it to write your mathematical terms. So for example, here I'm using this slash frac AB. So this would give you the fraction A by B and then x squared. So I'm writing it between the $signs. X squared, this is x1, this is square root of 2. So if I'll run my LaTeX document, this is how the output would look like. When we are dealing with these equations in Word, we have lots of challenge trying to adjust it and put it here and there, but all these things are not there in LaTeX at all. Now, we just talked about mathematical terms. Now, for more complex or standalone equations, you can use the equation environment here. So what you will do, you'll write slash begin equation. And inside this, whatever equation you want to write, you can simply write it and then you'll end your equation. Let us see it with the help of an example. So first of all, of course, when you're writing the equations, you have to use these packages, AMS Math, AMS THM, and so on. And then you begin equation, and then you are also putting the labeling for it. Now you are putting x plus 1 square minus x minus 1 square equals to 4x. Once you run it, it is giving you the numbering as well as whatever equation you have typed there. This is also very good. Now, once you have typed all these equations, you want to align them. So for alignment, it has this command called begin align and end align. So once you use this, you can actually align your equations as well. So here, let's see. For aligning, we are using begin align, and then whatever equations we have written here, and then end align. And once you run it, you will see that your equations are all very well aligned. Now, we want to align it from right. So for aligning it from, so this was only for simply aligning it. You have mentioned this n% equal to sign here. Once you have to align it from the right, so you write the n% sign on the somewhat like this. So it will be aligned from the right side, right alignment. And we have also used this FL align. All right, and now for writing matrices. So if we want to write the matrices, actually it's an essential part of mathematics. Any document you are preparing in mathematics, you will come across one or two matrices here and there. So LaTeX provides very simple environment for writing them. If you want a basic matrix without any bracket, you can simply use the matrix environment. And if you want square brackets around your matrix, you will use this B matrix. If we want simply the parenthesis on both sides of the matrix, you will write the P matrix. So let us see this tutorial here. So we are using /begin matrix, and then we are ending the matrix. Simply we have written that. If we are using B matrix, we'll get the big square bracket. P matrix will get the parenthesis. So let's see. This is how it will look like. This is how you can write your matrix in LaTeX. However, when we are writing the same matrix in Word, we literally have to build it every time, like size. We have to choose the size there, and then we have to enter it. That complexity is not there in LaTeX. Yeah. Now, in all the mathematical documents or mathematical papers, theorems and proofs are its integral part. So when we talk about theorems and proofs, so LaTeX provides very special environment with this command /begin theorem. Okay, so here we write /begin theorem /end theorem, and it will give you whatever you're writing in between. That will come out as a theorem. That will be written like a theorem. Here simply you can write /begin proof, end proof, and then you can write your proof here. Let us see a tutorial here. So here we are writing this theorem. Whatever is written between, it will come as a theorem, and whatever is written between these begin proof and end proof, that will come as a proof. So this is how it will look like when we will run theorem 1. Now we have written the statement and then the proof separately. Okay, so this is an environment for LaTeX that LaTeX provides us. Okay, I also told in the beginning that LaTeX makes it very easy to cross-reference sections, figures, tables, and equations, right? So what do we use? What commands are there? So first you place a label command where you want to assign a label. Then later you refer to it using /ref for the number, or page ref for the page number. So we'll see the tutorial for it. So here we have this section where we are using this, we are labeling it, and then we are giving the reference and as a number, or reference as a page number. So you run it. So here, this is the introduction section. We'll refer to it later using this we have mentioned here. And as mentioned in section 1 on page 1, the introduction outlines the background. So here we're getting the numbers, section 1, page 1, and so on. So this is a very good feature of LaTeX. Now, the bibliography. This is one of the most powerful features of LaTeX in handling bibliographies. So you create a bibliography database file, usually with a .bib extension. Okay. and use /bibliography command and /bibliography style commands in your document. And once you use it, LaTeX then automatically formats citations and references according to the style you choose. So, for example, here we are using this bibliography, and then we are mentioning whatever is in there, and it will come as a citation would come here, something like this.
Hello, ma'am.
Yes.
Yeah, as in the example, you have written the bibliography, and in the curly brackets, you have written 9.
Where?
The 9.
Yes, yes, yes.
I read in somewhere it is 9, it is 0, it is 10, it is 100. What is actually means?
So, where is 0? I don't see where is 0.
The place that you have put 9 here, right? The begin the bibliography bracket 9.
Yeah, and then
sometimes we use 0, sometimes 10, sometimes 100. So
Okay.
what is the logic behind this? Means I'm not getting the logic for this 9.
Yeah, I'll tell you. Okay, so when you are using this bibliography, so here actually I have written 9 and all these things, but generally you will see that many of the references that we take that are available online. Okay, it is there in some of the citations are there. You just want to call from there. So when you are taking the citations online from there, so you are using whatever is mentioned there, and you mention it here. Okay, that is how we do it. So there's yeah.
No, that is I got that point, but I am not getting the logic behind this 9. If we put 9, if we put 0, the result will be same. So if we put 100 here, the result will be same. Means in the PDF file, the reference will be listed. What is the logic behind that number 9? Means can we put, if we have put 9 at that place, if we are using such environment, we will use 10. If we are using another environment, we will use 0, like this.
Yeah, I got it. So I never thought about it actually. So whenever I had to use, I just pulled out the citation and I just called it. So maybe this is interesting. We can see it further. Okay.
Okay. Thank you.
Yeah, thanks. So if you want to have your presentation more attractive, we can always use this Beamer presentation. Here LaTeX actually gives you the Beamer that you use /document class Beamer. You mention your frames, the slides, whatever where you want to write it, and then the title page and so on. So here I have showed an example. So here we are using the begin document, begin frame, a frame title, and then whatever we have to write inside the frame, that is mentioned here. And this is how the presentations one slide would look like. So inside the frame, one frame would be one slide and so on. So you can end it and then you can start a new frame and you can make your presentation. Now for error handling also we have, do I have time? Do I have time or should I end it? Can I just check with, because I think the time is over, right?
Yes, ma'am.
It's 11:55, I guess.
55. It's already 55, right? Should I?
Yeah, we have 2 minutes, ma'am, I guess.
Okay, all right. Okay, so yeah, so I'll try to wind it up, kind of. Yeah. Okay, so yeah. So now, while working with LaTeX, it's very common to encounter errors. And if you see an error, it's completely normal. Whenever you compile your document and an error occurs, the LaTeX generates a log file. All right. So in that log file, the details of the error is always mentioned. Many of the times, the common error that you would see is some packages missing, okay, or some command has been misspelled, or you haven't closed the environment where you're writing, okay. So all these things you can see in the log file. In the log file, it's mentioned. For example, this one error occurs here, and in the log file, if you go, it is mentioning you the misplaced alignment tab character ampersand. Okay, so here the alignment ampersand sign here, there is error, so it will show you clearly where is your error. Now there are some inbuilt templates in LaTeX. If you use those templates, it is much easier to write your document in a desired form. Okay, and many a times you will see these templates. If you're writing a thesis, there are thesis templates available for different universities, For example, IITM thesis, BHU thesis, and so on. You can straight away use those. For CV, there are standard templates that you can use. For journals, the template is already mentioned on their site, so you can simply call them and you can use them. So you don't have to worry much about, okay, how we are going to write our document in this particular style for this journal, because it's already there. They have used all the packages that you might need, the font size, the type of, like the font size, the page size, everything they have included in the template that is available for given publisher. Okay. Now, some of the best practices that we have is that while using the LaTeX, some of the best practices that you can think of while working effectively with LaTeX is you have to use this version control systems like JIT. Tracking changes is invaluable, especially in collaborative projects or large documents like thesis. So you should do that. Now you should comment. Use this comment generously to explain the complex parts of a document. You should split large documents into multiple files. Okay, and there are several benefits for it. The navigation is easier. It is easier to edit. Compilation will be fast, and so on. Now, some of the resources available for helping you to learn LaTeX and troubleshoot the errors in the LaTeX are mentioned here. CTAN, that is Comprehensive Tech Archive Network. Overleaf Learn, it's available online. Tech Stack Exchange. All right, so all these things are available that you can use and clarify your doubts, or you can learn more about LaTeX. So yeah, that is all. I think I finished in time. Thank you very much.
Thank you, ma'am, for that insightful. I hope the participants are well acquainted now with the basics of LaTeX writing, how to present and how to apply all the equations and everything. Now I would like the participants to ask queries with ma'am one by raising their hands or typing their queries in the chat section.
लोकनाथ को फोन करना पड़ेगा.
Abdullah Khan, please.
Am I audible?
Yes.
My query is if we have text written in the MS Word, okay, like different subsections are there, different figures, tables are there. So do we need to basically copy the text and then write in the LaTeX, or how basically program on LaTeX? Do we need to paste the text, figure, table on that particular format, or how to basically? That's the question.
Okay, so yeah, so actually, if you already have a MS Word and you have to make a parallel LaTeX file, then the only thing that you can copy paste are the texts. You cannot copy paste a figure, you cannot copy paste a table. So for that, I already told you the commands and the package. So you have to use those, and you have to insert the figure using that use package graphics, and then you have to build the tables and so on.
Okay.
Only thing that you can copy paste is the text.
Okay. Thank you.
Any more questions? Next question, please. Anyone address if you have any queries.
Ma'am, there is any video in insert. If we try to insert a video in PPT format, then is there any command for inserting videos or animated videos?
In the PPT?
Yeah.
Yes. There is a command. Yeah, there is a command.
Okay. So, where we found that command file, because when we use LaTeX, there is no any help book or any something like that.
No. There is a book. I mentioned there in my presentation. There is a book. You will see those commands there. Actually, I use it very often in my presentations, LaTeX presentations. There is a book by Lampert. Okay. In that book, you will see. I also inserted it as a figure here. This one. Okay. I have removed it, right? Just a second. I'll share it again. You will find all these commands and everything here. Let me just share it. Yeah. Can you see it my screen?
Yeah, ma'am.
Yeah, this book, LaTeX Beginner's Guide, is a very nice book. You'll find all the commands here. So go and please check it. But there is a command
Okay.
for including the video. I have included in my PPT. If
Okay.
you want,
Okay.
I can check. I can open my PPT and check it and tell you if I have that much time. Yeah.
Yeah, okay. Thank you, ma'am.
Thanks.
Next question, if anyone wants to ask.
Um,
Hello,
Good
ma'am.
morning.
Conversion is possible MS file into a latex file?
No, sorry, not possible. You have written once the LaTeX. Once you have written a document in Word file, you cannot simply convert it into LaTeX. You have to write it from scratch. The only thing that you can do is that you can copy paste whatever abstract or introduction that you can copy paste. But there are also the references you have to again work on. Citations you have to again work on it. You have to call, first of all, you have to create a bib file, then you have to one by one call that reference there. So,
Okay, ma'am.
Next question.
Good morning, ma'am.
yeah.
Ma'am, this is Manisha Naidu.
I'm
Can
sorry,
you explain how to add headers and footers in the document?
Manisha, you are not audible actually. It's not very clear. Uh, can you missed
Yes,
it, right?
ma'am.
I didn't use it. But I'm sure since my talk was a very introductory, I'm just giving the introduction to LaTeX. Why should you use it all? I'm sure in the coming lectures you will get an answer for that.
Okay, okay. Thank you so much, ma'am. Thank you.
Oh, thanks. Yes, Abdullah.
My question is basically like if we have a 50 list of references,
Mm-hmm.
like 49 to 50 references are there. So if we have a list of all the references, do we really add all the references or like one by one we have to write
You
in the
have
LaTeX?
to,
Otherwise,
yeah.
time taking.
Yeah. Actually, you have to one by one insert those LaTeX. But technically, you have to call them from somewhere. If it is there, if it's not there, then you have to write it. And then once you have written the bib file, once you create the bib file, then you just have to call this whatever reference you have. As I told you, cross-referencing, whatever reference you have given, reference name you have given, you can just call it and use it in your file. But you have to create it like many a times.
Okay, one by one.
Yeah.
Fine. Okay, thank you, ma'am.
Okay, thank you very much.
Ma'am, the question of Harita, does latex work the same on Windows and Linux or there are differences?
No. So, for example, as I said, the files are portable. All right, the files are portable, so you can whatever file you have created in for Windows, actually you can use it in the LaTeX as well. The text file that is completely okay. It won't be any problem. You might have a little bit of a problem of packages here and there if there is an issue, but that you can fix. So files are portable. Okay.
Okay, ma'am. Thank you, ma'am, for this insightful session. I hope everyone's queries are sorted somehow, but as there is a paucity of there is less time and we have the next session scheduled. So, on behalf of the organization, I would like to thank ma'am for giving her time and putting so much efforts for making this session a wonderful one. On behalf
Thank you.
On behalf of everyone, I would like to convey heartfelt virtual applause to our felicitator for gracing this workshop with her presence. Thank you very much, ma'am.
Thank you. Thanks a lot.
So thank you. Really, it was a very interesting and interactive session. So thank you very much for accepting our invitation, Professor Neetu Kumari. And yeah, so now we are going to take a screenshot. So I'm requesting to all of you to just switch on your cameras, please.
Thank you very much, Professor Mathur. It was very
Please
delightful interacting
switch on
participants.
your camera if possible. Yeah. Okay. Yeah.
Thank you.
Thank you very much, Professor Mathur. Thanks a lot. So I'll leave now. I have a class. So yeah.
Excuse me, sir. Is there any feedback link or attendance link?
Yes, so we are going to start our next session, and in the next session we have the speaker from ABB IIIT Gwalior, Professor Anurag Singh. She is the Associate Professor of Mathematics. So, yeah, Professor Anurag Singh.
Hello, Dr. Mathur.
Yeah, so how are you?
Yeah, I'm good. I'm good.
So, thank you for being with us. And for the formal introduction, I would like to request to IOC, please introduce our speaker.
Again, without further ado, I would like to invite our next felicitator for today's session, Dr. Anurag Singh. Dr. Anurag Singh is an associate professor in the Department of Engineering Sciences at ABV, Indian Institute of Information Technology and Management, Gwalior. She holds a PhD in mathematics from IIT Roorkee and brings over 12 years of academic and research experience with interests spanning mathematical biology, nonlinear dynamical systems, information security, artificial intelligence, and machine learning. Additionally, she has led multiple prestigious projects funded by SERB, including work on ecological and epidemiological modeling, nonlinear system control, and graphic theoretic methods in large scale models. She has supervised several PhD scholars in areas such as bifurcation, delay dynamics, and discrete ecological systems. Dr. Singh has published extensively in reputed international journals, and she has published 37 papers in international journals. Her research has appeared in Mathematical Methods in the Applied Sciences, Journal of Applied Mathematics, and Computing Communications in Nonlinear Science and Numerical Simulation, and many more. Recognized for her contributions, she has received the INYS membership, ABV Young Faculty Award, NHBM Postdoctoral Fellowship, and several international travel grants, including ICTP and DST awards. She has also organized workshops and FDPs on mathematical biology, dynamical systems, and data science. Her expertise integrates theory with practical computational tools, contributing both to fundamental research and its applications in health, agriculture, and cyber security. On behalf of organization, I would like to welcome ma'am to present her topic on working with equations and mathematical expressions in latex. Over to you, ma'am.
Thank you, Priya, for such a nice introduction. And thank you, Dr. Mathur, for inviting me for this talk. As my lecture based on working with equations and mathematical expression, and this will be an interactive session, and I'll use overleaf. I hope that all of you are aware of the overleaf. It is very friendly portal for the latex user, so everybody can use this because it is online available. You just make account, you will get the facility to write your project or a paper or your PPT. So now I'm going to start with overleaf. So I request all of participants, if you are they are having the laptop or desktop with them, so they can log in and start the overleaf. So I request all the participants, and now I'm going to share my screen. This is, yeah. Yes. So now my screen is visible to you.
Yes, ma'am.
Yeah.
Yes.
So
Yes, ma'am.
yes. So first of all, let me know, because this is a totally interactive session. So please let me know, are you aware of have you heard about the overleaf?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Yes, sir.
Yes. Yes, if we talk about the latex WinEdit, so we can install in our system, but sometimes we can't have the latest one, the latex that the template and all the things, and then we have a online portal, online interface, and that is the Overleaf. So first I made account on Overleaf. It is totally free. So here what I'm going to do, here this is a new project. Okay, when you make an account, so you will get this kind of the window, and you will make a new project here, the new project. So there are 4 options here. You can see, yeah, so blank project, example project, upload project, and import from GitHub. So Overleaf provides so many options, so that suppose this is the option for upload project. If we talk about upload project, if we are having a zip file containing the bib file and the text file and figures, so and it is in zip format, so by using the upload project like this, we can select a zip file and we can start our project. So it's name called a project, and you can rename it. And here what I do, I start a blank project. Okay, and I write here the name, so GNU talk, fine. So this is going to create. Comfortable, everyone? So now what I do, I am going to share one that kind of the tutorial or something you can call that. This is all the simple mathematics symbol and expression I'm going to discuss with you. Okay, so because I have to give a lecture on the mathematical expressions and all, so I'm going to discuss all these things. So here this PDF file is visible to you, simple mathematics symbol and expression, yes or no?
Yes,
Okay.
ma'am.
No, it is not visible. I think so. No. Okay.
Not visible, ma'am.
Okay.
JNU talk.
No,
PDF
not
file.
JNU talk. Okay, you are presenting. Think. Okay. Stop presenting. Just a moment. Yes. First, see this. Simple mathematics symbol and expression, right? So I'm going to discuss all these things. Now, it is visible to you guys?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So now I'm going to start. Fine. So now yeah. Here. So what I do, so when we start any project, it looks like that. Okay, so this is the GNU talk and the title, and because this is my user ID and the date. So what I do, I'm going to remove it, and I am pasting something like this. Just a moment. I'll explain each and every line. Don't worry. So yes, see this. So because we are going to use some mathematical symbol expression, so and what is the meaning of each and every line, because this is the preamble of the file. So what is meaning of that? So first line is the document class. First we start with the document class 12pt article. It says that it is visible to everyone. Yes. So it's
Yes, ma'am.
so article, this show the 12pt article with 12pt font size. Okay. Next is the use package, AMS math, AMS sim, AMS theorem. So AMS provides advanced math features. Okay. AMS sim add many useful math symbols, and the AMS THM helps in creating structured theorem. This we have to write these because these are the specific package in Overleaf, and it is used in the we use any kind of the platform or interface in the Latex you install in your PC, or you use a Overleaf on online mode. So we have to write a preamble. So this is the use we have to use these packages. Okay. Next line is use package graphics, AMS sim, AMS font, AMS BSY, AMS math, AMS theorem. So this is a standard package to include images. So because the use package is graphics, we have to include image. Next is a use package, hyperref, standard package to include images, another one. Next is the use package input TNC. So this is for the character encoding along the use of international characters. Next is the use package, the float row, the improve the placement and formatting of figures and table with advanced control. Use package float, control the placement of float, ensuring they appear where specified. Suppose sometimes we want to put our picture on the bottom, sometimes we want to put our picture or figure in the bottom or the top. So by using the use package float, we will adjust this figure or we will adjust their appearance where it should be kept in your file. Next is the use package EPS to PDF. This package converts EPS file to PDF format. And similarly, the use package some figure. Sometimes, suppose we are having some figure, so it has a part, the figure, suppose figure 1A and 1B. So one figure, one has two. So that's why we use none of subfigure in a figure environment. Okay, now and the use package any size. So we have to adjust the page margin for the should be written in the preamble when we write any mathematics content. So this is a new theorem, lemma, example, proposition for the mathematics content. So sometimes we have to write the corollary, proposition, remark, definition, result. So these are some standard lines to include in your preamble. Next is the use package line number. So it show the enable line numbering throughout the document, because when we communicate our paper, so sometimes the paper there should be the line number, so that the reviewer or the editor should identify where we have to correct our manuscript. Next is the use package enumerate. So it enhances list formatting with more options, including we write some document in Word, so we have to put the bullet number 1, number 2, number 3. So it is used for the use package enumerate for this numbering. And these are the margin size. It's up to us that how 2-3 centimeter from the left, the 2 centimeter from right. So these are the standard thing. And the use package color, because we have to write colorful